So I just wanted to make a quick video following conversation and sort of thinking process in lesson today, talking about task 2. And not that you have to respond to this, but as a possible suggestion for how you approach task 2. So if you remember, you're using the data in the spreadsheet on Usain Bolt, Amber Anning and you in the 200 meter. And you've got to basically analyze the segment data and discuss any variations, comparisons between the three athletes. What we're trying to do is now show that you can apply your understanding of A1, A2, A3 and A4 content that you've already explained in task 1. So you don't need to define or explain what these things are anymore, but you are required to discuss the impact of them on each other and on performance of those three athletes. So again, a little reminder that the reality of task 2 and the reality of how we use our data is different to the theory. In a way, we're not going to talk about displacement and use displacement to calculate velocity. We're going to use the time taken to go round the 200 meters, not to cover the distance between the start and the finish. So that's just something to bear in mind. We're basically going to be talking about velocity calculated as if it was speed. Now, in lesson, I may have talked to you about using these slides and going through the A1 content, the A2 content, the A3 content, the A4 content, and then presenting it as you wish. But what we came up with today in lesson was perhaps not going by the biomechanical content, but by going through the race. And what that might mean is if you choose to do it this way, you're going to approach it from the start to the finish of the event and compare as you go along. So we want to get in, for example, maybe start by looking at the overall event. What type of motions were present? Well, we start with curvilinear motion around the bend and finish with rectilinear motion. No, nothing much to say about that. It's more an observation. Then you could, for example, go, well, okay, 3 athletes, what's their overall 200 meter average velocity? Effectively 200 divided by the time it took them to complete it. And then you can say, well, actually, this is interesting, but not that interesting and not that meaningful, because what we want to do is get beneath that and analyze how they performed within the different phases of the race, the start, the middle, the finish. So then you look at what's going on in the blocks, and that's where you can talk about mass. The mass of each of the athletes is different, therefore their inertial mass is different, and the momentum of all of them in the blocks is going to be 0 because there's no velocity. You could show that you obviously get weight is mass times gravity, so in brackets you can talk about the different weights of the athletes. Principles being, the heavier they are, the bigger mass they are, the bigger inertial value they are, the more force they will have to generate to accelerate from the box in order to gain momentum, that kind of thing. So that's kind of like the start of the race. And then what you do is you look at the first 50 meter data and you discuss each of the 3 different athletes in comparison with each other. Who had the greatest velocity by 50 meters? What's the implication of how their momentum change, mass times velocity, compare between the different athletes? What does it show? What do the acceleration graphs show about their acceleration? Who accelerated the most rapidly? And of course, I think you've got an acceleration time graph. So you could say, looking for the first 5 or the first 10 seconds, whose graph was steepest and what does that imply? Who had the highest peak velocity? Did they reach peak velocity by 50 meters, or did they get faster in the next time interval? So really just addressing those questions about that segment is kind of what you need. You're discussing how mass affects momentum, affects inertial, resistance to change motion, how velocity affects momentum, how velocity affects acceleration. Then you can look at this middle section of the race. Now you may find there's not a lot of variation in the middle section of the race, middle 100 meters. Of course, if there is, discuss the differences. You might want to lump that together and, okay, let's look at 50 to 150. And then, of course, you want to look at the last bit. Now, if you haven't already, and if it hasn't naturally happened with your times, no offense, what you could do is change your last time to make you slow down quite a bit. And that gives you a discussion between the three athletes of potential fatigue, etc., etc., etc. So really these questions, looking at velocity, looking at changes in velocity, looking at momentum, which is change in motion, looking at acceleration and or constant velocity or deceleration, that's what you're doing in all of these. And then what you could do is finish overall by discussing what you think the athlete's kind of strengths and weak aspects of their performance were. You know, did somebody accelerate better? What could be somebody's bit of improvement in the first 50? What might affect that? How can they train to improve that? Did anybody rapidly fatigue, and therefore what can they do to train for that? You know, identify through your linear motion analysis what their strengths and weaknesses are. It's just discussion really. But this, from the lesson today, I think could be another way of approaching this task too, and it kind of makes it make sense. You analysing the performance rather you forcing the performance into the sections of the biomechanical content. So task 2, written in the assignment brief, what you can do, if you go about it this way, just delete those little subtitles I'd put in there saying speed and velocity and all that jazz. If you want to go about it the other way, where you look at A3, A2, A4 in their own right, you can by all means do that. Just a suggestion.